we're moving into, I wanted to start graphing today. I'm just not sure if you guys are ready for it, but identifying the vertical and horizontal asymptotes and the non-permissible values are probably at least 60% of what you need to know to graph. So first of all, always keep in mind, eventually you're going to be writing that final exam, right, in January. So the final exam for pre-cal is not broken up into top unit topics. In the applied math and essential math, they give you the title of the question you're working on at the top. They say probability, and the next 5 questions are all probability. Applied math does the same thing, right? They have functions, and they have all the function questions. In pre-cal, it's different. They expect more from you, to be honest. So their questions are all jumbled up. They'll just say graph this, solve this, and it could be one from any of your eight units, and the types of questions are just jumbled together, scrambled. So one of the things is, you know you're talking about a rational function, because that's the chapter we're doing, right? But I want you to get used to the fact that when it just says use the equations, determine this info, or graph this function, I want you to get into the habit of looking at the y equals statement and categorizing in your mind what function you're working on. So the first thing I do is I recognize that all of the functions I see here on this page are rationals as well. Sorry, they're all rationals, correct? Now, how do you know they're all rationals? There's an x, at least one x, sometimes more. There's an x in the denominator, right? X in the denominator means they're rational. Anytime there's an x in the denominator, there's going to be either a vertical asymptote or a hole in the graph, right? So that makes your graphs completely different than most of what we've graphed before. So first of all, use the equations to identify non-permissibles. The non-permissibles are easy, right? It's all the values of x that would make the denominator 0. Now, I look at the bottom and I just make sure, can I factor the denominator anymore? No. Okay? So therefore I can proceed right to just identifying my non-permissible values, right? And in this case, what can't x be? And NPV stands for non-permissible values. X can't equal -5. All right? Because if it equaled -5, my denominator would be 0 and my function wouldn't exist, right? The whole equation would be impossible. So my non-permissible value, x can't equal -5. How did you get that -5, Carlos? You saw it with your eyes, right? Set the denominator to 0 and solve for x to find the NPVs, right? You're just doing that so automatically now, you don't even need to really do that, but that's really what you're doing in your head. The only reason I'm writing that out is because sometimes if the denominator gets a little trickier, it's nice to have like a system, a fallback. Okay, my non-permissible value is x equal -5. As soon as I find my non-permissible, that gives me my vertical asymptote. The equation of the vertical asymptote is just the opposite of this, x equals -5. Agreed? Horizontal asymptote. Now I gave you a set of rules. What will the horizontal asymptote be equal to in this case? I have x squared on the top and x on the bottom. Y equals 0?
The numerator is higher than...
Yeah, so what does that mean? There is none, right? It's not 0, but there's none. There's no horizontal asymptote, right? Now, it didn't ask me to graph, but let's just say it did ask me to graph, okay? In my head, what would this quick sketch be? It would look like I'm doing this very quickly, right? So x equals -5. Here's -5. There's my horizontal asymptote. All it asked was for non-permissible values, and the asymptotes, I'm just gonna push this one a little further. What else would I need to know in order to graph? What are two other really valuable pieces of info? For any graph, what 2 points should you always try to identify their values, or if they even exist? Yeah, the intercepts, right? X-intercept, Y-intercept. Who was that? Who said that at the back? Johannes? Okay, Y-intercept's easy. All the X's disappear, and I'd be left with negative 25 over 5. Oh, sorry, I don't even know. Something's wrong here, right? If I was going to graph this, I would factor everything. Agreed? Yeah. So I'd have X minus 5, X plus 5, and I think, Eileen, you said there's something wrong here because we get a whole at X equals negative 5. So this isn't a vertical asymptote, sorry. It's a whole. I didn't do my... It's a whole at X equals 5, so I'm going to have to redo this. My X-intercept, I replace Y with 0, and I solve for X, so X equals 5, and I'm using factored form. So actually I should probably do a different. There's my X-intercept, there's no asymptote, there's no horizontal, there's no vertical, and my Y-intercept, let's see, replace X with 0 in my simplified form. Y equals 0 minus 5, negative 5. So it's just a linear function with a whole, and the whole is at negative 5, so this is what I would do, right? And that's what my graph would look like. Okay, so that's where we're headed today. So let's just answer the questions. So I guess I should factor all the time, factor numerator and denominator, factor first before we identify anything, because I fell into that little hole too. Okay, I can't factor anything in these two, right? They're already simplified. I can't do any more factoring. So, non-permissible value, I'm going to pick on someone. Who said that? Brahim? Johan? Non-permissible value, X can't equal 2. So that gives me my vertical asymptote, right? Is there a horizontal asymptote? 5, right? Y equals 5. That's it. Okay. Can this one be factored at all? Okay, let's factor. Negative 2 plus 1? Okay, who wants to be brave? I don't want to pick on anyone, but I want a little bit of input. Neville, do you feel like being brave? Okay. What happens when I have a common factor here, right? So what happens? They cancel, right? As soon as I cancel out, what does that mean for the graph? Do you remember what that means? Because this isn't my vertical asymptote doesn't exist anymore, right? It's gone. So I'm just going to have a linear function. So when I have a common factor, it's not a vertical asymptote. It's going to be a whole. That's what happens to X values, because we know there's always going to be an X on the bottom, right? At least one. All those X's on the bottom, they're either going to result in a vertical asymptote or a whole. One or the other. It's got to be one or the other. And if it's not vertical asymptote because it canceled out, there's a whole at X equals negative 1. Okay? That's gone now. So no vertical asymptote, but there's a horizontal asymptote at, higher power on the top, so there's no horizontal asymptote either, right? This is just going to result in a linear function with a hole in it. Agreed? So your x's on the bottom always result in wholes or vertical asymptotes. If the factor doesn't cancel out, if it's left, it results in a vertical asymptote. If it cancels out, it results in a whole. All right, let's factor the next one. Plus 7 minus 1. Okay. Does the denominator cancel out? No. So that must mean that, well, first of all, my non-permissible value is x equals negative 2. I guess I should have done my non-permissible value here too. Non-permissible value, x can't equal negative 2. It's a vertical asymptote then at x equals negative 2. Higher power of x is on top than bottom, so no horizontal asymptote. That's it. I got my non-permissibles and my asymptotes recorded. Okay, what about this one? Again, it looks like I can factor the bottom. And it's the same as this one, plus 7 minus 1. Sort of the same sets of numbers, but completely different now. No canceling, so no wholes, non-permissible values, x can't equal negative 7, x can't equal 1. These are both vertical asymptotes then, right? At x equals negative 7 and x equals 1. Is there a horizontal asymptote? Higher powers of x on the bottom, so what does that mean? Y equals 0. Okay, what about this one? Okay, I'm going to give you a minute to try that one. Okay, how did we do? Is there any canceling to be involved? No factoring, nothing I can cancel. So is there a non-permissible value? Is there a there should always be a non-permissible value because there's always going to be an x on the bottom. So there's always non-permissibles. Yeah, x can't equal negative 3. So this time it's a vertical asymptote. How about horizontal asymptote? Well, there's more x's on the bottom, so it's just like it's this, right? There's x on the bottom, nothing on top. That results in y equals 0. So horizontal asymptote would be y equals 0. Okay. Okay. Questions? Now, let's take a look at the homework you were assigned to do. I don't know if you did it or not. So it was on page 115 and 116. Before we move forward to graphing, I just want to talk about this. All right, so how many people, be honest, did the homework as well? Like you were working on the hand and did you do homework? Did you do this? Yeah? Okay. So for each of the following, find the vertical asymptotes and state the domain without graphing. So once again, same thing as we were doing, right? You're just setting the denominator, you're factoring everything, setting the denominator equal to 0, identifying vertical asymptotes, horizontal, or just vertical asymptotes, and then the domain. So we're good with that? So what would the domain be? In this first question, like if I just picked, I don't know, let me pick B. All right, so B was y equals 8 over 4 minus x squared. So what's the first thing you would have to do in order to identify non-permissibles? You have to factor, right? So you'd get 2 minus x, 2 plus x. Now they just were focusing on vertical asymptotes this time. So x can't equal plus or minus 2, right? So I'd have vertical asymptotes at plus or minus 2. Agreed? So this is just focusing on the x info, vertical asymptotes. That's why they asked you for the domain. So what would the domain of this graph be? Yeah, that would be the easiest way to write it, right? X could be any number, any real number, except not plus or minus 2. That's it. Agreed? Okay, second question, now they're focusing on the horizontals. Do it without graphing. So I pick one of these. Let me pick C. So C, y equals 2x squared plus 3x over 3x squared minus 48. Now if they're just talking about horizontal asymptotes, I'm not worried about the vertical this time. So all I do is focus on the highest powers. There's matching highest powers. X squared over x squared, so they cancel. So that leaves me with my horizontal asymptote. Y equals 2/3. Agreed? When the powers are the same, the coefficients of the same exponent term will be the horizontal asymptote. When there's higher powers on the bottom, like here, horizontal asymptote is y equals 0. If highest power is on the top, we don't see one of those, then there is no horizontal asymptote. Now once again here, this is my asymptote, so what will the range be? Well, kind of the same thing we did on the first part. Y can be anything except y can't equal 2/3. That's it, right? And then here, for each of the following, they wanted you to put everything together, just like we did, all the asymptotes, but then they also wanted you to identify the domain. And then for the last question, it wasn't a huge assignment by any means. They just wanted you to match graphs. Now I know some of these graphs were kind of hard to read, but each tick represented 1 unit, so you could kind of count there. All right, did you find this matching isn't that, probably not that hard to do, but any questions on this one at all before we move on? Joanne, any questions? No? Okay, let's move on. Okay, I guess we're ready to start sketching actually. So on page 14, let's put all this together and let's see what graphs look like. Hi. So get started on page 6, or on page 14 and back. start without me. All right, these are the important things we need for graphing. Graphing rationals. Absolutely non-permissibles. I'm just going to write, even if we don't end up with a vertical asymptote, I'm going to go through my list, because if there isn't one, then I'll just put none. And I'll write down whole. There may or may not be one. Horizontal asymptote. And as we said earlier, x-intercept, y-intercept. So this is my little list of the absolute minimums you need to graph a rational function. And like I say, some of these might end up being just like none. There might not be one. Okay, there's always going to be a non-permissible value though, and it's going to lead to a vertical asymptote or a hole. There always will be a non-permissible. So, Eduardo, you're with me. What's the non-permissible? So x can't equal -2. Now, I don't know yet. I have to factor, right, in order to figure out completely what's going on with this graph. That's why we spent all that time like on factoring and reviewing it, right? Just to be able to do this quickly without having to think. And as I said before, when you get into these tougher units, like the rational stuff, they're not going to give you super duper hard ones to factor. They're going to be straightforward ones. Okay, so I have a canceling here, right? So what does that tell me regarding, is it a vertical asymptote or a hole? It's a hole, right? A hole at x equal -2, and there's no vertical asymptote. Now I'm not done here, because the hole is a coordinate point, right? And I have to also figure out what my y-coordinate is, because I'm going to have to plot that hole. So, how do I figure out the y-coordinate? Well, I just plug, after everything's canceled, I just plug my -2 into the statement, right? -2 minus 3, -5. Okay? So those are the coordinates of my hole. -2, -5. That means, I mean, I could even plot that right now. -2, -5. Just so I don't forget, I'm going to have a hole.
How do you figure that out? Like the actual
Well, here's my statement, right? This is the statement I was left with. This is my equation now. My equation used to be this big thing, but I reduced it to just y equals x minus 3. Okay? So if y equals x minus 3 and x is -2, -2 minus 3 is -5. Yeah. This is the statement you're going to use. Use this simplified version to find holes and intercepts. Okay. Now, the reason is, look what would happen if like you have to use the simplified form, because I know there's a hole at -2, right? If I use this whole big unsimplified one, look what happens when I try to find my hole. You can't, right? If I used my unsimplified version, x minus 3, x plus 2, x plus 2, and I'm trying to find y when x is -2, because that's my hole. Look what happens. -2 minus 3, -2 plus 2, what happens? You just get a 0 on the bottom, which is not possible. You can't even do it. You can't even go further. You have to use the simplified version for moving forward for any holes or any intercepts. Okay, what about a horizontal asymptote? I have x squared on the top, x on the bottom. None. Perfect. Now, what about x-intercept? All right, we put a 0 in for y. Remember, simplified version. 0 equals x minus 3. So x-intercept is 3. That's important. Y-intercept. Put a 0 in for x. Y equals 0 minus 3. Y-intercept is -3. Okay. Now, put this all together. I always draw in asymptotes first. That's my first thing if there are any. In this case, none. So, but I know what this is, right? This is a linear function. And I have enough info, I don't think you even have to do much more to it. My x-intercept is 3. My y-intercept is -3. And I have this whole, so it's just gonna look like a linear function, right? X minus 3. And I think we could probably give the domain and the range. XER, x can't equal -2. Now this is important, you need your whole to get the whole complete domain and range. Y can't equal -5. Okay, so I'm going to stop there for a moment. Are you okay?
Yeah, I'm really tired. And I wasn't here on Friday, so I'm kind of lost.
For people who were here on Friday, is Eduardo, you had a question?
Wait a minute, hold on. So we can't have a holder at -2 even though the asymptote is -2?
There is no asymptote. Non-permissible value, those non-permissible values will become either a whole or an asymptote, not both.
Oh, okay.
If there's a whole, there's no asymptote. If there's an asymptote, there's no whole.
Okay.
And the reason it became a whole is because it was a common factor, right? So you either go, once you identify your non-permissible, you got 2 roads to take, but they're in opposite directions, either the vertical asymptote or the whole, not both. Okay, Johannes? How did I get the range? Well, the range, there's only one non-permissible value for the whole. If you have a whole, there's a non-permissible y value, right? Y can't be -5, but y can be everything else, right? Yeah. If there's a whole, that means there's going to be one y value that's not allowed either. Yeah? Any other questions? Now's the time to clear them up, because this was an easy one. Fairly easy, right? Yeah. Jovi? Or you're just stretching? Do you have a question? Just stretch.
So, when you did -2 minus 3,
Yeah.
where is -3?
It came from this statement, right? This is my equation of the whole line, right? This is my set of instructions for this particular situation. So for this graph, y equals whatever x is, subtract 3. So the whole occurs where x is -2. So if I know x is -2, I just substituted that in, like table of values. -2 minus 3 would be -5. Yeah.
Wondering if the values switch from negative to positive, but it doesn't, right?
No, no. This would just be like if I could actually have graphed this whole thing with a table of values, right? I could have done a table of values, old-fashioned way. The only thing about table of values is they take so long, and typically, you guys don't have a lot of time to do, like you would never have time to complete the whole exam if you approached the exam and did every single graphing question with table of values without all this background knowledge. Like you just wouldn't have the time, it just takes so long. But basically, Jovi, like I'm putting in a 0, and that's going to be -3, right? Put a 1 in, that'd be -2. If I put a -2 in, like I did there, it'll be -5, right? So you could have done this all negative, like with the table of values. That's all we're doing here when we find our holes. Okay, so we're trying to do a whole big exposure to all types here. Okay, sketch this graph. All right, first thing, always factor if we can. I'm going to do my little list here again. It all starts with non-permissible values. Those either lead to a vertical asymptote or a whole. And sometimes you get both, like if you have 2 factors of x on the bottom, maybe you'll get a whole and a vertical asymptote. Horizontal asymptote, x-intercept, y-intercept, domain and range. Okay. It looks like I can factor this one, right? 2x squared all over x minus 5 x plus 5. Carl, you want to do start me off? Do I have any canceling? So no canceling, no whole. What are my non-permissibles? Yeah, and I could write it together like that, right? And that no wholes, because there's no canceling, so they're both going to be asymptotes. X equals -5 and x equals +5. No whole, nothing canceled. Okay, let's take a look at the horizontal asymptote. What can you say regarding the powers of x on the top compared to, like, the highest power on the top bottom? They match, right? So when they match, they just kind of cancel out. So I'm left with the coefficients, which would be y equals 2. Okay. What about x-intercepts? Yeah, how do we solve for an x-intercept? Again, put a 0 in for y, right? And then solve for x. Okay, so sometimes this is hard for students to see, but I'm trying to solve for x, right? I got a 0 here, so I would kind of do a cross multiply, right? These two multiplied together have to equal this, so 0 times anything, I end up just with 0, right? So I get 0 equals 2x squared. So x-intercept must be 0. Agreed? Okay, I'm going to move these guys down. I should move. Okay. Now, if my x-intercept is 0, that means my y-intercept has to be 0 as well, right? Because if you have an x-intercept at 0, that's also going to be your y-intercept. But I can prove it to you too. So my y-intercept, same thing, right? I replace x with 0, y equals 2 times 0 squared over 0 squared minus 25 if I use this form, so it's just going to be a 0, right? And I knew that. My y-intercept is 0. Okay, I think I'm ready to graph. I'm going to start with my asymptotes. So at plus and minus 5, so again, vertical dotted lines where your asymptotes are. Okay. Vertical asymptote here, vertical asymptote here. And my horizontal asymptote at y equals 2. Because those kind of give me my boundaries of where my graph is going to be, right? They really help you a lot. They contain the sections of your graph, so you know what you're working with. Okay, so now I'm going to identify my intercepts, but I really only have one of them, right? That doesn't really help me out a ton, actually. After all this work, I've got one intercept. Now, remember, graphs can never cross vertical asymptotes. Sometimes they can sneak across a horizontal, but never across a vertical. So the vertical asymptotes are the guidelines that divide your graph up into sections. So there's 3 sections I see. This one, and this one. Now, I don't really know what's happening, unfortunately. Sometimes my intercepts help me out a lot more than they do here. But there's nothing at all happening. I don't know if my graph is on this part of the grid system or this part. So unfortunately, I'm still left with having to do some test points. Okay? So when I say test points, I'm looking for a value of x in this section. So I'm going to do a test point. All right, so it's got to be anything less than -5. Anyone want to give me a value less than negative? It can't be -5 because that's a non-permissible, but anything to the left of -5. -6 then? Let's do -6. Okay, what does y equal? Y equals, okay, here's my statement, right? And it's not really I can use either form, by the way. Sorry, either form. Because nothing was canceled out, so I can use either one of these. So what's y going to equal? 2 times negative 6 squared over negative 6 squared minus 25. This is going to be some kind of a fraction, I think. Let's see. I'm just curious to see, really honestly, if it's at top or the bottom of this. And I think it's going to be on the top. Because it looks like I'll never really get a... yeah, so I get about 6.5. Would you agree? Okay. So at negative 6, it's going to be about 6.5. Go here. All right. Now, I could do another test point, but at least I've done one. Because typically what's going to happen is, I know there can't be anything underneath here. And what do asymptotes do? They create these boundaries for your graph to kind of grow to. So I know my graph is going to grow here. And then I also know my graph is going to grow this way, right? It has to. There's nothing else for it to do. It's always going to stay positive, and it's going to stay, very rarely do your graphs cross a horizontal asymptote, and this is kind of a regular looking type graph. That's what asymptotes do, right? The graph just grows to it. Okay, let's do this section too. I can see that if I do a test point of 6, just knowing how squares work, I'm going to end up with the same y value, right? 2 times 6 squared over 6 squared minus 25. Because of the way the squares look, it's still going to be 6.5. So I'm going to have another point here, and it's going to do the same thing, right? They grow towards the asymptotes. Okay. So there's my wings, but now I got something happening in here, right? Now I know that I'm probably going to dive into the negative world here. But we still need to do another test point, right? Give me a value for x somewhere in this domain from like negative 5 to positive 5. Oh, I can't do negative 5 or positive 5, right? Because those are non-permissibles. I would get zeros on the bottom. Negative 4. How about positive 4? It's always easier to use positive numbers, right? And in this case, 4 and negative 4 will be the same value. So let's see. Y will equal 2 times 4 squared over 4 squared minus 25. So that's going to be 32 divided by negative 9, I think. 3.5. Negative 3.5. Okay. So when x is 4, y is negative 3.5, okay? It's going to have the matching value at 4. All right, does that give you an idea of how this graph, what this part of the graph will look like? Yeah, kind of like, I could do more test points, but I'm just interested in if you get the shape, at least, you know, one test point. Okay, so your vertical asymptotes will divide your graph up into sections, and you should do a test point in each section, unless you already are lucky, and maybe you get lucky and get some intercepts in a section. You might not have to do a test point in a particular section. I just wanted to make sure that this graph actually indeed grew down, which it does. Okay, I want to give you a minute. Tell me what the domain and the range of this graph are. The domain should be straightforward. The range might be a bit tricky. Eileen, what's the domain? plus or minus 5, right? Good. You want to try the range? The range is tricky. Okay, okay. So the range is, we're giving it, Dillahai says negative infinity to 0. I'd agree with that, right? Agree? Or, what's the next section? 2 to infinity, right? And 2 and infinity are rounded brackets. Only the 0 is included. So this is a weird one. There's a section between 0 and 2 with no y value, right? It's blank space, so I can't include that. That was tricky, that one. Okay. How about you guys go for a 5-minute break, and then I'm gonna. If you don't want to go for a break, I want you to work on this one on your own, and then I'll go over it when you get back. Yeah. So let's see. Yeah, okay, so we're doing ranges?
Domain.
Yeah, but range?
Range?
I want to talk about range. So it starts at 0, okay, right? And then it goes to 3, and that's it. So 0 to 3, right? Yeah, okay, so let's do domain now. So it would be, yeah, see, I'm going to show you something. So when we do this, yeah, it's lying on top, but it's still, it's not bubbled back. So it actually is, oh, I see what you mean. I see, right?
We chose those -6, but we can't choose 5.
Here, I guess let's call it negative 2.
Yeah, that's what you're asking. Yeah, exactly.
How about negative 1.4? Let's say negative 1.4, and then this is negative 3.5 to negative 2.5. I think. Yeah. Yeah.
Yeah, and then it won't work. Exactly. So we can't do
And
that.
then this one,
Is that
then it's infinity. Yeah, then it's infinity. Yeah.
Also, this is
Yeah.
the correct.
Let's see.
There's a absolute value is maybe above.
So absolute value. Yeah, so nothing would change there, right? Same. Yep, same. Because absolute value just means everything is above. Yeah. And then this one, square root.
Yeah, I'm gonna do this, but I'm gonna do it on paper.
Is this the square root one? So I think from 0 to 1 it would be this though, right?
Oh yeah.
And then it would be like this.
Yeah, this is all from this.
Okay.
Oh, I would just.
Do you have a question?
So we do that. This one.
Okay, so this is what we did. That looks good. So here, is this A or is this B? This is A minus 2y. That looks good. This one, whatever value this is, you multiply that by the opposite.
Oh. So it's
Just like we did the transformation, right?
Mhm.
Wow.
Same thing. And here you're gonna have to factor, right? Factor that 2 out.
No, this one. I don't understand. Right? It's the
That's
power.
the inverse.
Yeah.
Yeah, so whatever your values are here, right? Whatever your x, y values are f of x. Here.
Opposite.
Yeah.
So
4, 3, -7, -1, 5, 0, right? You just flip
Make it
the x's and y's.
optional. Or not a negative mostly.
No.
Oh.
Try to do it how you think. Yep.
that's what I'm doing too.
This is what we did here. So it's something I do this one.
Okay.
That
So I would do this one, y equals, and this one, y equals. What is this a graph of? X plus 3, what kind of graph is that? Yeah, so draw the linear, plot that right here. No, this is the y-intercept. Y-intercept is 3.
3, right?
Yeah,
That's what I see. One.
so it's here. Yeah, then you slope is 1, up 1, over 1. So that's what it would be. So redo that one.
That's the solution. I think when you check both of these answers, you get a 2. This one works, but this one doesn't work. So they're going to meet at this. They should meet at. What's wrong? Yeah, they should meet right here.
Oh,
Negative 5, 0.
factor from
Negative 4, 1. Negative 1, 2. Right? This is y equals x plus 3. This is y equals root of x plus 5. And wherever they meet is the solution.
okay. So this is the one we talk about. We have to check the
Yeah, you never have to check your graphic one,
okay.
but you also check the algebra one.
And I need you. This is what is top when it's sorry, what's that?
Oh, yeah. But
This is when
if I do like high power on top,
yes, I
low
will.
on bottom, no horizontal asymptote.
Okay, when it's top.
High on the bottom, horizontal asymptote is y equals 0. And if I have 2x5 over 3x5,
I'm gonna do that.
horizontal asymptote equals 2 over 3.
It should be one.
Yeah, well, yeah, gotta be one of these. All right, how are we doing?
Question.
Yeah.
If there's a hole, that just means that there's no vertical asymptote, can there still be a horizontal asymptote?
Yes. Very rarely. You'll,
Is it possible to have a vertical with a hole?
A vertical was a hole?
a vertical asymptote and a hole?
Yeah.
Yeah. Yep. You can, I'll show you a picture of horizontal asymptote, no vertical. It would look like this. Take the end of doing one. It would look like that. You might get something like, I don't know, like 2 over, x, what's it, let's say I have x squared plus 4. No value of x. There's no non-permissible value, right? There's no value of x that would make it non-permissible. Because even if I put a negative in, it's always going to be positive. So this is a case where there's no non-permissible. I think I'm going to say there's always one of those. No non-permissible here. But highest power on the bottom, so you still have your y equals 0 as a horizontal, right? Agreed? No vertical asymptote, no hole, but it has a horizontal asymptote. Right? I think we see one of these guys. They don't pop up that often because they're not really that interesting, I guess. But okay, so I left you before the break taking a look at this one. It looks like there's lots of parts. So first thing I'm going to do is factor. I'm just going to actually section off my last question. Okay, so we have y equals 2x plus 1 all over. I'm thinking 2x plus 1 probably is one of my factors.
Excellent.
Yeah. Okay, so here's my rewritten factored form. And I'm going to write all my info down again. I always have to consider the vertical asymptote, the hole, and then I'm going to do my x-intercept and y-intercept. Okay, these guys cancel, right? I guess before they cancel, I should say my non-permissible values, x can't equal -1/2, x can't equal 3, right? I'm just setting both of these factors equal to 0 and solving for x.
0.
X could be 0. Yeah, because a 0 wouldn't zero anything out, right?
Oh,
Yeah. Okay, so there is a vertical asymptote at x equals 3, and there's a hole at x equals -1/2. Okay, the holes are problematic because they require actually quite a bit of work. I have my x value of the hole. What's the y value of the hole? What's the y coordinate of the hole? Okay, so this is what I'm left with, right? I'm left with, by the way, what is the simplified equation? Y equals 1 over x minus 3, right? Okay. So that's what I'm going to use to do all my intercepts and holes. So what do I have here? I'm just going to move down. The y coordinate of the hole, y equals 1 over -1/2 minus 3. Oops. This is where your fraction work, right? So what does that equal? 1 over -3.5, I guess, which is, just going to keep kind of using all my 1 over -7/2. So 1 over anything, the fraction just flips, so that would be -2/7. So y equals -2 over 7. It's going to be kind of hard to see on a graph, but what is 2/7? 2 divided by 7 is 0.3 about. Okay, I'll just keep that in mind. Okay, is there a horizontal asymptote? Let's see. No. Well, I have more x's on the bottom than the top, right? So that means y equals 0 is my horizontal asymptote. Okay. I'm going to give you a moment to figure out what your intercepts are. I'm going to let you try that. I'm going to get you to do your x-intercept and your y-intercept. I'm going to sketch in my asymptotes.
if we get an intercept, we're using 1 over x times 2.
You always use this form for all of your substitution work, for holes or intercepts. Y-intercepts are always the easiest, right? Because it's set up for you in y equals form, so you just have to do a substitution. Right? So what's your y-intercept? You just put a 0 in for x, right? Y equals 1 over 0 minus 3, -1/3. Agreed? Okay. X-intercept, put a 0 in for y, and I get 0 equals 1 over x minus 3. I do my cross multiply, and I get 0 equals 1, which is nonsense, right? So what does that mean when I get a nonsense statement? An untrue, impossible statement. No x-intercept. And that makes sense because my y-axis is the horizontal asymptote. Okay, so what have I got to graph here? I got to graph my horizontal asymptote, my vertical asymptote, and my hole. I'm going to do that first. So here's my horizontal asymptote. My vertical asymptote. The more stuff you have to plot on your graph, the better it is for you in the long run, right? And my hole is at -1/2, -2/7. So -1/2, negative like 0.3, somewhere around here. Okay. And then my y-intercept is -1/3, which is, I guess, right here, right? So I can kind of see what's happening here. I have a point and a point, even if it's a hole. I don't know, do you guys, I've got two sections of my graph, right? Because vertical lines break your graph up. I've got this part and this part. Even with these, only these two little pieces of info, do you feel confident graphing what's happening here? You have 2 points and you have 2 asymptotes. So what do you think your graph is going to look like?
It's gonna get confusing.
Yeah, they always go towards the asymptote. It's like the asymptotes are magnetized, right? So and these are, it's a function, right? These are curvy graphs, so they're just gonna approach, right? That's what they want to do. They want to grow, they're magnetized, they're attracted towards the asymptotes. Because that's what asymptotes, the definition of an asymptote is. It's a line that the function grows towards without ever touching. It wants to get closer and closer to it. So I'm confident that's what's happening. We could do another test point. If you wanted to do another test point, I would do something like, I don't know, like 2. If I did a test point x equals 2, just to reassure myself, y would equal, again, I'm just using this version, right, the simplified version. Y equals 1 over 2 minus 3, negative 1, which is negative 1. So at 2, y equals negative 1, which is what I thought was happening, right? So I'm just going to do, my 1/3 is a little off. It's closer to half, so it's about here. Okay, so I think I'm just going to connect my curves. And then my graph just keeps approaching the asymptote and running alongside it, getting closer and closer. And same thing with my horizontal asymptote, getting closer and closer. So here's one section of my graph. So this whole side of the graph is done, right? Why am I confident that nothing's happening up in this section?
Because it wouldn't be a function.
It wouldn't be a function, right? I can't have anything here. Now I have to figure out what's going on this side, though. I don't really know if I'm pretty sure it's going to be another wing. I just don't know if it's diagonal or side by side. So we're not given any info here. So I for sure have to do a test point. I think I'm going to make it easy on myself. X equals 4, right? This is a test point. Because that's an easy one to do. Y equals 1 over 1. Like 4 minus 3 is 1. So 4 comma 1. Okay. Are we okay with doing this?
So we only do the second test point to figure out if it's on the top, bottom, right side.
Yeah, once you know all, because you already, I think so. I mean, because you already know, you've done all the work of finding the asymptotes, and you know what asymptotes mean. They mean your graph is going to grow towards them, right? So as long as you can kind of locate where the point is, and then you're just going to attach your graph heading towards the asymptotes. Yeah? Okay, look what happened. We get this guy. We were just talking about him, right? Maybe I should stop. We'll do him, and then we're going to leave number 5, and I'm going to leave him for a reason. And then I'm going to get you guys graphing. Okay, what's happening here? Same old deal. We have non-permissibles. I have to identify holes, vertical asymptote, horizontal asymptote, x-intercept, y-intercept. All right, so I look. Can I factor it all? Nothing to factor. X squared plus 1. If it was a minus 1, it would be difference of squares, but it's a plus 1. So can't factor. If I set this equal to 0, right? X squared plus 1 equals 0. x squared equals -1, that can't happen, right? X equals plus or minus root of -1, can't happen. So that means no non-permissibles. And if you think about it, of course, any number I put in for x, whether it's, even if it's a huge negative number, two negatives will become positive. I'll never ever end up with 0 on the bottom. So that's fine. If there's no non-permissibles, there's no hole, there's no vertical asymptote. But is there a horizontal asymptote? And why is it y equals 0? I agree. Why? Yeah, there's higher power of x is on the bottom, there is x on the top. Okay, x-intercept, y-intercept. What's the y-intercept? 2. And x-intercept? None. Okay. If I put a 0 in for y, right, if I put 0 equals 2 over x squared plus 1, I cross multiply, I get 0 equals 2. That's nonsense. That means there's no x-intercept. Okay. Now what's weird though is, so let me put my, the only thing I have is I have a horizontal asymptote at 0. That's all I know. But I also have a y-intercept at 2, which is really weird. This is a very strange graph because for the first time we see that it is possible for the graph to cross a horizontal asymptote. Never ever a vertical, but sometimes they cross horizontal. But other than that, that's the only info I have. So what does this graph look like?
So you have
Or sorry, not x-intercept, y-intercept of 2. Sorry guys. Sorry, that's wrong. So what does this graph look like? What else can you guys? We have to figure out what's going on, right? There is no vertical barrier, but I do have a horizontal asymptote. There is no x-intercept, so it's not like it crosses it at all. So I know my graph is going to hug the, right? It's going to kind of grow. I'm pretty sure it's going to grow down and hug. So let's do a test point. And again, because of this squared value, whatever test point I do of 4 will have the matching value at -4. So let's try x equals 3. So y equals 2 over 3 squared plus 1, 2 over 10. Which is 0.2, a very tiny little number. So when x is 3, y is going to be just really close to the x-axis. Same thing will happen over here. So I guess just remember no sharp corners, right? Make it nice and rounded. And that's about all you can do for this guy. This is an unusual one. There's really not much to it. But if you just follow the rules, right? Factor number 1, go through your little list. You might not need them all the time. For example, we found out we didn't have the info here, but it keeps you organized, right? It makes yourself, I guess, aware, gives you an awareness of all the parts that could potentially be in a rational function graph. Okay, how compared to when you came today, is this, do you feel that you could handle graphing rationals a little better than you did? Or the same? Maybe what? How do you feel about these guys? No? Okay, well, you're going to get some